Standards are all around us. Sometimes we don't notice them, even though they're right in front of us. For example, this is a picture of the Appian Way in Italy, very near Rome. The road hasn't changed much since the time of the Romans. A bit further down the road, you can see something rather interesting near the catacombs. The road is made up of the original paving stones placed there by the Romans. Look at the ruts in the stones. The ruts have been worn into these stones, and they are exactly 4 feet, 8.5 inches apart, all along the Appian Way. The ruts in the stones of the roadway had to be created over many, many centuries. But why are the ruts 4 feet, 8.5 inches apart? It turns out that the Roman war chariots were pulled by 2 war horses, and the chariot wheels were set far enough apart so that they would be just to the left and to the right of the rear ends of the horses. Given the size of the war horses the Romans used, that meant the wheels needed to be 4 feet, 8.5 inches apart. Now jump forward a number of centuries to railroads and the Flying Scotsman. This famous train was the 10 a.m. from London to Edinburgh. Its rails were 4 feet, 8.5 inches apart. That's not a coincidence. What happened is that the width of the tracks in roads became a standard gauge for railroads. 60% of all the railroads in the world today actually have a gauge of 4 feet, 8.5 inches apart. Now, jump forward about another 100 years when America began the space shuttle program. The space shuttle had solid rocket boosters. Those tubes, just to the right and the left of the space shuttle, are solid rocket boosters made in the state of Utah by Thiokol. The size of those boosters was actually set by the 4 feet, 8.5 inch standard. And the reason is because while the boosters were made in Utah, they had to be transported to the Kennedy Space Center in Florida. The aeronautical engineers wanted solid rocket boosters that were actually wider and more powerful, but they were limited to the 4 feet, 8.5 inch standard because that's what could be transported on United States railways. In order to understand standards, we need to understand the standard-setting organization's policies, their licensing standards, and some user perspective. Let's talk about some standards that you're probably already familiar with, such as the light bulb. Let's say that you're sitting in a room and it's after dark. You probably have an electric light. There are any one of a number of light bulbs you might be using. It turns out it's pretty easy to change bulbs. Does it make any difference which manufacturer you buy your bulb from? It could be a bulb that's manufactured by GE, or it could be a bulb that's manufactured by Sylvania. If I'm replacing a United States standard incandescent bulb, it turns out that the number of screw threads per inch and the width of the screw threads will be exactly the same on each of the light bulbs I purchase, regardless of the manufacturer. And each of the light bulbs will be rated for a specific amount of light. A 60-watt light bulb, a 100-watt light bulb, and so on. The standard that a light bulb manufacturer adheres to will allow me to purchase from different manufacturers and expect exactly the same performance from that light bulb, regardless of manufacturer. Notice that the base of the newer compact fluorescent bulbs is exactly the same as the older incandescent bulbs. The manufacturers have met the same standard in order to ensure operability. So what do we exactly mean by a standard? A standard is a set of criteria. Sometimes these criteria are mandatory, but more often than not, they're voluntary guidelines, they're best practices.